Chemistry, specifically organic chemistry, has been categorized as a difficult or hard concept to grasp, but in reality, it's really not that hard. And the goal of this video is just to kind of break it down and break down its fundamentals to the easiest possible way. So, before we start off going into organic chemistry, we need to learn about chemistry itself, and we need to define what it is. So, chemistry is simply a study of elements and how they react with each other. That's it. That's literally the definition of chemistry that I got straight out of the textbook. Now, of course, there's a lot more definitions to chemistry than that, but I think that's the one that I like too. So, now we can define organic chemistry, which is the study of compounds which contain carbon, and in most cases contain hydrogen too. Now, carbon is really interesting because it is the basis for all things organic, for all things life, which is like why it's called organic chemistry, which is just like carbon and how it interacts with other molecules. So before I get into the science, I'd like to talk history a little bit because it wasn't until the 16th and 17th centuries that any significant progress was made in the isolation of organic compounds. The first ones discovered were methanol, ethanol, and acetone, and these compounds were extracted from dry distillation of wood. Now, of course, later more compounds were extracted from plant and animal matter, such as citric acid from lemons, tartic acid from grapes, malic acid from apples, lactic acid from sour milk, and my personal favorite, uric acid from urine. In the years 1772 through 1776, a scientist named Lavoisier made a series of experiments on a certain type of organic reaction called combustion. And he identified the presence of carbon and hydrogen in these organic compounds, since the products of the combustion was water and CO2 gas. So an example of a combustion reaction would be, let's say, hexane plus oxygen results in water and CO2. Now, of course, for the reaction to take place, there needs to be heat added so that the oxygen could burn the organic material, and as a result, energy is released, and also steam and CO2 gas. So, as Lavoisier grew more curious, he decided to dissolve the CO2 in potassium hydroxide, and then was able to determine other elements in the organic compounds such as nitrogen, sulfur, and more oxygen. And then during the 19th century, as more and more elements were being added to the periodic table, it became more apparent that carbon, hydrogen, oxygen, and others like nitrogen were associated with living organisms. So, we've already got the history out of the way, so let's talk science. So, what is it about carbon that makes it so special? So, to understand why carbon is so important, we first need to talk about electronegativity. And electronegativity is basically how much an atom wants electrons from another atom. And typically, smaller electrons are more electronegative, and the ones with a nearly full valence shell are the most electronegative. So an atom such as fluorine is very electronegative due to its small size and almost full valence shell. So, to put this into perspective on the periodic table, electronegativity values increase going right on the periodic table and going up on the periodic table. So going back to carbon, it is the smallest element in group 4, and it has the highest electronegativity of those atoms in group 4. And it also has a valence of 4, which means that it can fit 4 more electrons. And this means that it can bind with a whole bunch of stuff because its electronegativity values aren't that different from, let's say, like oxygen or hydrogen or other compounds that it binds with. So another thing that's also really cool about carbon is its ability to form bonds with itself. This could either be in the form of a single bond, a triple bond, or a double bond. And carbon can also create a double bond with oxygen, a double bond with sulfur, and a triple bond with nitrogen. So carbon has this other cool feature that's called catenation, which is basically the ability to form chains of itself. And these chains could either be in the form of a short linear line, a long linear line, or even a closed ring system, which could form compounds such as benzene or cyclohexane. So now let's talk about some of the characteristics of organic compounds. And organic compounds are generally gases, volatile liquids, or low melting point solids. They are also typically insoluble in water unless they have a polar group, such as an OH, a COOH, or an SO3H. And as discussed earlier, they usually form a combustion reaction from excess amount of oxygen, which is the one that we showed earlier. But usually organic reactions are a lot slower combined to inorganic reactions and need more energy, typically in the form of heat, or as scientists like to call it, delta H. So another characteristics of organic compounds is isomerism, which is the ability of certain organic compounds to possess a different structure but still have the same or chemical formula. So a good example of this is C2H6O, which can be ethanol, which is typically found in alcoholic beverages, or dimethyl ether, which is a completely different thing from alcohol, but it is still the same chemical formula, so it's an isomer of ethanol. So to wrap everything up, organic chemistry is basically just the study of carbon and how carbon interacts with itself, how it interacts with other elements such as oxygen, nitrogen, sulfur, and phosphorus, and even some of the group 7 halogens, if not most of them. So I think it's really cool how these elements are the ones that is responsible for us. Basically, our existence in life is based on carbon being able to bond with 4 other things. And I think that's really cool about organic chemistry. And I hope you guys enjoyed this video. It was a lot of fun talking about it and making it. So yeah, let me know what you guys want to see next. Bye.